Okay. Good morning, everyone. Today is day 14 of the solidity bootcamp and last day. Amazing. I already started. And today I just prepared like a little list on the tools that you can use for developing a full stack application from the front end to the smart contracts, right? We have already seen all about solidity and developing smart contracts and deploying them to testnets, doing tests on smart contracts using Foundry, using some hardhat as well. But we haven't checked on the list of available tools that we have online to use, ready for us to use and build a full stack application, right? So something that you can deploy to, you can deploy, ship your front end, and everyone else can use it. So I'm gonna start with Beam, which already you introduced yesterday. This is not gonna be some technical workshop. This is just gonna be noting down the list of available tools that I personally use, and some of them are available to everyone to use. And then I have used before, but I don't have as much experience with. But I will mention them as well. So to start, I'm going to start with Beam. The Beam is a library for connecting to smart contracts from the front end. So by the way, almost all of these libraries that I'm going to mention are written in JavaScript or TypeScript. So they mostly function on the JavaScript environments. For example, if you use React or Next, or even the framework that you mentioned yesterday. If you're used to JavaScript and TypeScript, this will be cool for you. And also, most of the applications in the Web3 ecosystem are already being built with JavaScript and TypeScript on the interface side. Also on the backend side. So yes, most of the tools are in JavaScript, and Beam is not the exception. So Beam is this library that you can install, and it will let you connect to contracts and send calls to contracts and get results from contracts directly with this library. So for example, these are some functions that you already covered yesterday. With Beam, you can create public clients and create wallet clients to fetch some data from the blockchain or to write some data to the blockchain. Right? Here is the documentation. I will add all these links to a list so that you can check them out later. But for now, you can just follow me on the list. Right. I will try to be as quick as possible because I will cover many of the tools, and you can check the documentation later. I'm not going to try any of these commands for now, but I'm just going to try to explain what any of these libraries do. So yes, so this is Beam. You can start checking out the documentation. You also have a migration. If you come from an Ethers environment, you can change to Beam. And as you remember, Ethers is another library for connecting to smart contracts from the front end, also written in JavaScript. And you can import Ethers like this and use it like this, right? Setting up a provider, sending transactions, and signing transactions as well. So Ethers and Beam are kind of similar. It depends on which one you like the most. But for developing environment, I recommend using Beam because that's what the teams are currently building on, or the most popular one. And if you already used some of the other technologies that I'm going to tell you after this, you are already using Beam in the background, so Beam is cool. You can check everything that you can do with Beam. Here it has a client and transport section. You can set up public clients, wallet clients, like you said yesterday. I don't know, some customizations on the transport protocols. Here you have a list of actions that you can do with Beam after you install it, of course. Every one of these tools can be installed with npm, pnpm, or yarn, depending on what you use, right? And here you can see all the functions that you can call. Getting block numbers, of course, watching transactions, estimating gas, which is pretty useful for when you want to try a contract function before calling it, right? You want to try if it will fail or not, and then after you have the result, you can call it. Yeah. So this is basically Beam, and then you have ethers, which I already mentioned is kind of the same. You have to set your provider, and then once you set your provider, you can send transactions. For example, this one, getting the balance of this address, right? Well, that's basically it. Just connecting smart contracts to frontends, right? And fetching data and writing data to these smart contracts deployed on the local net or testnet or mainnet. So you can check ethers as well. As I said already, you should check out Beam because I think it's cool. And another tool that we have here is WACME. You can check WACME. And WACME is just a set of especially if you work with React or a React environment like using Next, for example, you can just install WACME and use WACME hooks for getting data from the blockchain. WACME uses Beam in the background, so if you already know some Beam, you can abstract some of the Beam functionality with WACME, and it's going to be like a higher level code. Like with WACME, you can customize the calls, but with Beam, you just get something straightforward that you can call and get some data. I will show an example here. Yeah, so you add WACME like this, and of course, to add WACME, you need Beam as well. And they also use some time stack, which is a React querying library, right? So here's how you create just a basic Beam configuration, and then there's a quick example over here that I can show you. Yeah, so here. With just a simple use account hook, you can just get the address that is connected to the application, to the web application, right? And as you see, it's pretty simple, and you don't require any state update logic. You don't require using state or using effects. You just call this hook and you get the address as a result, right? There's also another example here. Use ENS name that from an address it translates to the ENS that this address has. Okay, so this is pretty simple. You have a lot of other hooks that you can use here as well. You can check the documentation if you want to use WACME. So in summary, WACME is just React hooks that get that fetch data from the blockchain and write data on the blockchain. Same as WACME, same as Beam, but on a higher level. Then you have wallet connection clients like I don't know. Let me see if I can show you an example. Yeah, like this one. I'm pretty sure you have seen these ones around all Web3 applications, where you click a button and you get like many options to connect your wallet to. One of the most popular, of course, is MetaMask. So this button here is made with RainbowKit, and RainbowKit is this library that you can just install to your application and get this button as fast as possible to connect any wallet and use it in your application, right? You can install RainbowKit with these commands, of course, and you can import it like this. As you can see, RainbowKit also uses WACME hooks. So if you're familiar with WACME, you can already use RainbowKit for this. I can see you, yes. And if you only need like the connect button, you have a section here that will let you just how to add this button in your application, right? It's pretty simple. Once you set up RainbowKit, the RainbowKit library with the configuration, you can just import this connect button component and use it in your application, and you will get this functionality, right? There's some other wallet tools that you can use. For example, I use this one on some of my projects with my teams. This is Web3 on board, and as you can see, it's the same thing that RainbowKit is, just same thing. you click on a button, and then the button shows this modal here that you can use to connect any of the wallets that are available. So here you have some options. Of course, you can customize which of these options you show to the user. If you just want to support MetaMask, you just show MetaMask. If you want to support other wallets, you can show them. And this one especially, Web3 on board, is pretty cool because you have a little widget here, a small widget that you can, let me see if I can show you. So yeah, this is the functionality from Web3 on board, from Block Native. In my opinion, it looks more professional than Rainbow Kit. I know it looks more sleek. It has some themes, of course, that you can customize. And it has some help for users that don't have a wallet to set up their wallet for the first time. So I think it's pretty good. And as I said, let me see if I can connect my wallet right now. You can see. Okay, so once you connect your wallet with Web3 on board, you get this little widget over here that will let you switch from connected addresses, connect another address, all straight from the interface, right? You can disconnect all wallets. You can see some information about the network and about the app that you're using, so it's pretty cool. You can set up some documentation over here, some documentation links from your application for users to check. And this is pretty cool if you're used to using applications on a full screen like this, and you can just switch or connect accounts from this little widget without having to close the full screen and switch to MetaMask and then do the switching from this, right? You can do it straightforward from here. I think this one's cool. I think it's secure. You can check it out on the documentation later. But as well, you can just install it with npm and then use it with a very simple import. Okay, so after learning about all these libraries, you can use Scaffold it. And we have already used Scaffold it in our speedrun Ethereum challenges. So Scaffold it is like this big packed framework where it includes Next.js, Rainbow Kit, WebMe, and TypeScript. So you already know Next.js is for building frontends, right? Interfaces. Rainbow Kit is for connecting your wallet. WebMe is for fetching information and writing information to the blockchain. And TypeScript is just a language that every one of these tools uses. So you can set up the Scaffold it pretty fast with this. npx create it latest, and it will spin up one of these applications that you have here. I'm gonna zoom in a bit so you can see. You have seen this interface already in our challenges before, and for a hackathon project or something that you wanna do very quickly, like in 1 day or 2 days, I recommend you use Scaffold it because it will spin up this whole development environment for your smart contracts, so that you can test every function from the smart contracts in the Block Explorer, in the Debug Contracts tab. And you can also have some Ether straight from the interface. You can create random wallet addresses, use wallet addresses in the interface without having to import or connect MetaMask, right? So I think you already know the capabilities of Scaffold it, and like I said, for a quick hackathon project, it's really useful. It also abstracts some of the functionality from these wallet connectors, from these libraries for fetching data, and yeah, I think it's pretty useful. It as well has some components for you to use right away. So, for example, if you want to use an address component here and display the address or display the balances, you can just call these components, and they look pretty nice as well. So you can get some pretty good looking UI in just a few clicks. It also has some plugins which I have no idea because I haven't used them, but you can check these ones out in the documentation as well. And yeah, as I said, it uses WACMI hooks for you straight away. It comes pre-installed with scaffolding, so you can just call the hooks from your coding, right? So here's an example of how to read a contract, and then you can use this contract to send any transactions. This one's pretty cool, the Block Explorer from Scaffolded. You can check every transaction that has happened in your local chain here or in your testnet. Especially useful in your local chain because once you deploy a contract on a testnet, you have a Block Explorer, right? But if you're using your contracts on a local chain, you can use this built-in Block Explorer to check the results of every transactions that you have called, right? Very, very useful. So this is scaffolded. Not much science here, just copy and paste this command and you will get one of these projects running. I recommend you test that one out, of course. And that's it for interfaces. Something that you can use quickly, fast, and it doesn't require as much as expertise with React or I don't know. Or it abstracts the Web3 functionality or the library from a front-end builder. So if you are more of a front-end builder and you just want simple components, connect to wallets fast, you just use scaffolding. Okay, so now moving on, I brought a little solution for storage here. And I think most of you know about IPFS. I will just check it out here. Oh, no, this one. This one. So IPFS, it's a decentralized storage network where anyone can store files, images, videos, or anything in this decentralized network of nodes, and it will live on this network forever. That's the premise, right? You just put something in this blockchain and it will stay there forever. This was created as a solution to the expensive storage of EVM blockchains like Ethereum, like L1s, right? And you can store these files in decentralized ways, and it uses some thinning service. It uses hashes to find the files. So it uses the content of the file, it hashes the content of the file, and this is used for the searching of the files, right? This is mostly used, for example, in the case of NFTs, where if you use a centralized server, anything can happen to the NFT image or the NFT video or the audio or anything, right? But if you use something like IPFS, there's a guarantee that this file will live on IPFS forever and that no one can change it, right? So this is why it's a preferred solution for images, videos, and basic just media stored in the blockchain. And there's an even easier way to interact with IPFS, because if you want to upload something to IPFS, you will have to set up a node and get something running. But if you just want to have an image and you want to use it right away in IPFS, there's this service called Piñata that you can use. And you will have like some free tiers that let you upload, I think, up to 100 files or images, if I remember correctly. And then you can use these files and get the URL for your smart contracts, right? Instead of using a centralized server URL, you are going to use a decentralized IPFS gateway. So I think this one's cool. I have used it before. And for decentralized storage, it's good. And for testing purposes, it's already good. Okay. And moving on to RPCs or URLs, there's this cool website called Chainlist that lets you navigate into all the networks that exist currently on the Web3 ecosystem and check details on every one of these networks. So let's just, for example, check Ethereum mainnet. You get the chain ID, you get the currency ticker, and you get a lot of public RPC URLs that you can use. For example, if you want to connect your MetaMask to a new network, some of these details will be asked. So you can just, let's say you want to add, let's say you want to add the blast network, which I don't have currently, right? MetaMask will ask you for the chain ID, the ticker, everything. If you just go to here, add network, and if you choose the manual option, you will be asked for network name, RPC URL, chain ID, currency symbol, and block support. So you can get those details fast in changes, right? You can get a chain ID, you can get the RPC URL, and everything will be. You can use that right away. And also for some backend applications, you can use, if you're just testing your application, you can use any of these public RPC URLs. This will have some throttling, this will have some limits, rate limits that, especially if your application is read-write heavy, you will be limited by this public URL. So in that case, or in the case that you are shipping your application to a mainnet, I recommend you just use Infura or any of these other services that offer custom RPC endpoints that you can connect to. I don't know if we saw this in the first classes, but for creating data from the blockchain and writing data to the blockchain, you need to connect to one node in the network, right? So this is why the URLs exist, and these RPC ones are just public resources that you can use in the chain list, for example. But for private usage or metric monitoring or some more heavy usage on mainnet applications, you should use Infura, for example, and I will let you see what it includes. So yes, here in Infura you can create new projects and you can use endpoints specifically for one of these projects. So let's say you're developing a new application that is called Mint, and you want to deploy this Mint application to the Polygon mainnet. So you can use this. You can use Infura to connect to Infura nodes and use these URLs for you to send read and write transactions to the APM. So for example, if I was going to deploy to Polygon, I would use this RPC URL. And you can have some cool statistics on your projects. For example, let me see. Yeah, you can just like how many transactions you have sent to this RPC URL, how many write or reads you have done. I don't know, monitoring is better for production applications if you use Infura, right? You should use Infura for production applications. Okay, so this is everything about RPCs that I know. Of course, there are other services that you can use. There's QuickNote as well. You can use QuickNote if you prefer to connect to the APM via these RPCs. It's another competitor of Infura, and you can also be part of these protocols by running your own node, and then earning some rewards. But I have never done that, so I have no insights about this. Okay, so now moving on to indexing data. I have brought today two solutions. One of these is Alchemy, and Alchemy is a well-adopted solution for querying data from the blockchain, because they have like a simple interface, API interface that you can use. I can show you some examples here. Let's say that in your application you want to know how much balance this user or user X, in this case Kate Kazak, has. So you would just call this function get token balances from the Alchemy API, and it will fetch all of the balances of all the tokens that this user has. as I said, pretty straightforward, pretty fast. It has a very fast setup. You just install the library, get your API token, and get it running. You have to add your API token to your environment variable, and you will get this Alchemy API access. Of course, the free tiers are going to be limited on the rate that you can use, how many of these functions you can call, how much time, how many calls per hour you can do. It's going to be very limited. They have a paid service as well for this. Okay, let's say that you're building an NFT marketplace and you want to fetch all the NFTs that one user has. You can just call this function here, get NFTs for owner, and it will fetch all of the NFTs that the user has. You also have some solutions for if you're building wallets. You can just get all the transactions that a user has made on his wallet address with this very useful function, get asset transfers, right? So pretty quick, pretty easy. A lot of projects use Alchemy, a lot of production applications as well use Alchemy, and of course they pay Alchemy a small fee because this is a centralized service. And that has to be pretty clear. Alchemy is centralized. And then there's a decentralized way of using or doing this, which is a little harder to set up, a little harder to get it running, and it does require a little more knowledge on querying languages, right? And this is the graph. The graph is another way to index data on the blockchain, and this is especially useful for when you have already your application, and your application needs its own data, right? It needs to access its own events. It has already some kind of business logic that needs to be queried in the blockchain. So let's say you're doing a DEX or a swap, and you need to fetch all of the transactions from your swap. You would set up your own subgraph and then access your blockchain data specific to your application. So this is a better way to do this. It's centralized as well. They have a decentralized structure behind the back. As I said, this requires a little bit of knowledge on GraphQL, and it also supports every of the most popular networks, right? Here it has some tutorials on how to set up your subgraph, and as I said, for every application that you develop in a production grade, you will need one different subgraph, and you will deploy the subgraph, and then you will use this to query all your data from the subgraph. And as I said, this uses GraphQL, so if you're not familiar with GraphQL, you can just take a quick look and start using it. But it's not hard, in my opinion, but it does require a little bit more diving into the documentation of the graph. But as I said, it's more secure and more decentralized, and more specific to your needs, I may say. With Alchemy, you just have predefined API codes that you can use straight away, but with the graph, you can define your own data that you want to fetch, right? For example, in this case, pools, the first 10 pools I want to fetch, right? So it's a more tailored solution for production-ready applications. Okay, that's it as far as indexing and fetching data from the blockchain that I have used before. I know there are more solutions on the Web3 ecosystem, but I'm not going to mention them today. And I found this pretty cool list on tools and protocols that you can use. It's kind of outdated, some of them. So if you already use some of these libraries and you know that the link is broken or the name of the application is outdated, for example, I found now here, scaffold E. You can just contribute to this repo and update the link, because this is an old repo. It has like 1 year or 2 years of age already on the last update. But here you can find some of the most popular tools on Web3 that you can use for your applications. So it has a very cool separation as well. Here is just a general list of protocols on resources to learn about blockchain. Here are some references on EVM. Here's a roadmap for if you want to become a pure blockchain developer from beginning to end. There's some cool DeFi developer guides as well. You have some communities that you can join here. to ask questions or see what projects are people building, right? You can just join these communities. There are some examples that you can use, example code. We have covered some of these development environment tools like Remix, like Hardhat, like Foundry. There's some DevOps that I have no idea about, but you can check it out. I know there's some DevOps guy over here. So there's some SDKs as well for developing mobile applications, right? Kotlin SDK. And there's some other libraries here on protocols that you can check. There's Wallet Connect, IPFS, Aave, the Graph, which I already explained, and some other more, right? And here are the JavaScript libraries that I already mentioned. As you can see, there are a lot of JavaScript libraries, but the ones that I mentioned are what you might need for an application, for a complete application, right? You have already Rainbow Kit here, you have Ethers, WAGMI, right? You can see them here, and that's it. There's some Go, there's some Rust libraries as well, and if you're a Python developer, there's just these little libraries here. There are more. I know there are some more right now currently. But if you prefer Python or JavaScript, you can also use these Python libraries for the blockchain. There are some boilerplate codes that you can use, and here it lies the Scaffold project. Like I said, this Scaffold takes you to an old Scaffold project, which is the Scaffold one. But if you want to contribute to this repo, you can update this thing to Scaffold 2, which is already the platform that has shipped from the guys at Scaffold. You can check any of these links. Pretty useful, and contribute with your own tools or links if you don't see them here. I will send this one out in the Discord server. So that's it for today's lesson. I hope you brought or you get some insights. You got some insights from this, and you take these libraries with you. You check the documentation, you use them, and then start developing your applications. I hope you are ready to code your own smart contracts, to deploy them in a testnet, to use front-end libraries for this. I don't know. Make your own applications. Now you know some solidity. Now you know some front-end, and you can just code your own apps from now on. So thank you.